I'm continuing on part 2 of the HSC examination, the 2017 HSC. We're up to question 13, and Okay, so the next picture that would be here would be a picture of an Allen truss. Now I have a picture of this because I took the exam, but it doesn't matter what it is because it was a stupid question and everybody hated it. If the person who wrote the exam ever watches, if I ever bump into that person, I'll feel bad, but I'll say, look, man, that was a hard question. That we very rarely speak about Allen trusses, and the picture was not a clear picture in black and white that could easily identify which members were which. So we're just going to skip it, and we're not going to feel bad about it at all. Now, question 14. This is a question that I knew my students would get because I have cracks at my house, right? Sorry, I was going to move around to the crack, but so how are we going to deal with cracks? So I have cracks in my house, and how do you deal with cracks? So I hate cracks. Yeah, drill a hole in the tip of the crack. I get a bit put on tilt with cracks. Okay, 15. How do we minimize significant loss of electrical power transmission in cables? Very high voltage. There's a song about that too. Okay. So yes, very high voltage, and AC current is more efficient than DC current. So that's why we use high voltage AC for power transmission. Okay, 16. Television programs, lower activity, often have a lower quality picture. This is because the signals are transmitted using. Okay, I'll be honest. I do not feel confident about this answer, but the answer is B, and we'll talk about. Well, we know it's digital modulation, right? So, analog TV signal has phased out in Australia and most other places, and if we're thinking we have poor quality, it's because it's high compression, not low compression. Low compression means big size, good quality. Yeah, that's right. Whereas high compression means small size, small quality. Okay, that's right. If you had a bag and you compressed it, would it have a big size or a small size? The stuff that's in the bag, would it now have a lower quality or a higher quality? Yeah, okay. So, okay. Which of the following does an impervious iron oxide layer provide corrosion resistance to bare metal? Okay. Well, that provides, yeah, that A is good. Yeah, A, we're going to go with. So, galvanization, yeah. Okay, the answer is D. Now, I don't even remember people complaining about this one, but they should, because this is, at the very least, even if D is right, it is a very, very hard question. I'm going to go on record as saying, look, if you got this one, if you said A, I'm with you, and, you know, I probably need to get on the internet and ask, hey, why was this one wrong? So, yeah, watch the space maybe, but probably not because I'm lazy. Yeah. Okay, now I think I put this in like your half yearly, this exam. Yeah. Okay, so they even tell you that proof stress is 0.2%. So we know that this is a progressive yield, like Kitty from Progressive Car Insurance, just in case future generations don't know what that's Kitty from Progressive Car Insurance. And when we have a progressive yield, it means there's no bend where there's an obvious yield point. So we go down, so we go to 0.2, so 0.2 is 1/5%, and we follow that line up parallel until we get to like somewhere in that range. I would say it's somewhere in the ballpark of like 120 something like that. 140? Yeah, that's in the ballpark. That's the answer. Okay. Now, again, I hate these questions because yes, it's important. Yes, it is in the exam. It's even in the book, but I just don't like them. So what we have is an explanation here on this next page, 65, where you can sort of logic it out, right? The smaller diameter has to be the number that is the thing that's going all the way through. So in this case, the 15 diameter, well, that 15 is being drilled all the way through. To show it's a spot facing, we put this sort of flat U shape. And then we say the next diameter is going to be 300. That's what we call a bore or a counter bore. And then we're going to go 15 millimeters down. Sorry, spot facing is above. I misspoke there. I'm not going to edit because I'm lazy, but a spot facing is the opposite of a ball. So it's when it's above. Okay, this one here is a countersink. It's just the same idea, but it's shown. We write a V. We say the outside diameter, and we say the angle. So if we go back to our exam, we see, okay, what have we got here? Well, we know that, so they're saying it's a spot face. I think spot facing should be above the ground. Maybe that's why I misspoke, but, yeah. Okay, so, I'm gonna live with it. I'm not gonna argue. Oh, that's the spot facing, this flat area out here. Okay, so that's the big area. Okay, then this one here is a counter bore of 10, and then down is 6. Now, we don't even have spot facing in the book, so let's have a look. How would I write that? Well, yeah, that makes sense. So we can cross B out. Okay, so it's going to be 6, 10. Is it 8 mil deep? Yep. So I'm going to say A is looking good. Right, let's have a look at the alternatives. So it needs to be 6 with this symbol, and it's not B. So it means, yeah, it's A. Okay. Now, this question here, pretty stupid. Now, it's a 20 marker. Sorry, not 20 marker. It's the number 20 multiple choice. They're supposed to be hard. They're supposed to be time consuming. Let's see how we do without a pen. Right? Okay. So first of all, just a second. The question we have is this a solid piece? Is this like a beam, or is this pinned? Well, so we can see a pin here, so that kind of indicates it's going to move. And although it's not clearly stated, we're assuming that there are pin joints there. So when we push down here, that will lift this up, and when we lift this up, that will lift this up. So, okay, there's 2 forces going down. What they're saying is that the load is being held down by the force of gravity, and we're putting our boot or some other dead weight on here. And what we do is when we lift that, we're going to lift up this point L. Now, what we're going to do is we're going to lift this a little bit, but we're going to lift this even less, and that's going to give us our mechanical advantage. Right? This one's going to travel, the effort is going to travel further than the load, and that's what's going to lift this up. So where this is going to move down, say 100 mil, this one here is going to lift up less than 100 mil. Well, we're going to figure that out. But okay, so how we can look at this here is the reason why I can't move more than 100 mil is because that's the thing of the pin. Otherwise, we get a problem, right? So this lever here, if we just ignore the rest of it and just say this lever here, what is the mechanical advantage of this lever? The effort is twice as long as the load. Yeah, if we just imagine that the load is here, if we had a seesaw, right? Fat kids always win at seesaw unless the skinny kid is further away, right? So in this case, he's twice as far away, so he's got twice the advantage. Okay, so we just keep that in our head. On this side here, how far away is this force, and from this lever this member going up here, it's going to lift up the whole thing. How far away is this force that's being applied here from our pin? From our 300, exactly right. Not 200, but 300. That's the trick. Yeah, 300. Okay. Now, how far away is the load from the pin? 100. So it's 3 to 1. So we've already got so it's like a wheelbarrow here, yeah? We've got our load in the middle, it's a wheelbarrow, so we expect an increase, right? We've got a 3 to 1 here, and we've got a 2 to 1 there. That will give us 3 times 2 is 6. Yeah? So if this goes down 100 millimeters, or let's say it goes down 90 millimeters, let's say it goes down 60 millimeters, this will only lift up by 10. Yeah? So what that will do is it will lift up a small amount, but that small amount might be all we need to Yep, that's it. Now, it's a tough question. We haven't done anything like that in our lead up to the exam, but the whole idea is they don't want, the new HSC, they don't want people knowing exactly what's going to be in there and say, oh, I've seen this question before. They want you to think, well, what would happen in this situation? They want you to be able to deal with the unknown a little bit, and especially when we get to the higher end questions. So here, it's kind of, well, okay, which one could it be? If you've never seen spot facing because it's not in the Copeland textbook, well, which one could it be? It's got to be one of these. It's either got to be A or B. And, well, it's not 8 millimeters. It's not 10 millimeters down. It said 8 millimeters down. It said it's 8 millimeters deep. So straight away you can eliminate B. and all the others are totally wrong. So that kind of helps us, right? That kind of helps us because they're trying to get you to apply your understanding a little bit. If anything, this is quite an easy question for question 18. Yeah.
Wait, what was 18?